type conversion and type casting. So when we assign the value of one data type to another, if the data types are compatible, then Java will perform the conversion automatically. So this process is known as automatic type conversion, right? If the conversion is not performed automatically, then they will need to be casted or converted explicitly. So if the two data types are compatible, and when we assign a value of a smaller data type to a bigger data type, automatic type conversion happens. So in our example, first we'll define the variable a with the double data type and no initial value. And then secondly, we can define the variable b with int data type and assign a value of 20. And then we assign a variable b to variable a. Because of the int data type is smaller than the double data type, this conversion is performed automatically, right? And this process is known as automatic type conversion. Say it with me. Good job. Now, if we want to assign a value of larger data type to a smaller data type, that's when we perform explicit type casting. So in our second example, contrary to the first example, we'll define a variable a with double data type, and then assign a value of 20. Second, we'll define variable b with int data type, but no initial value. And then when we try to assign variable a to variable b, unfortunately, this conversion could not be performed. And the compiler gives us an error. And you know why, right? Because the double data type is bigger than the int data type. So in these cases, you just have to explicitly specify the typecast operator. And that process is known as typecasting. So let's go ahead and open Eclipse and try to understand Java conversion and data type casting. In the exercise project, right-click on Data Type Package and select New Class. Specify the class name as Typecasting and select the checkbox for the main method. Now let's declare variable a with int type and assign 124 to it. Then declare variable b with long type and assign a. So in this process, there is no need for typecasting because the long type is larger than the int type. Now in the same way, declare variable d with double type and assign b. And here again, there's no need for typecasting because double type is larger than long type. So let's print the values of these variables by using our print method. Now, let's change the variable names and the other parts. Okay, so let's run the code. And you can see the results in the console. Now let's look at different situations that would need typecasting. So why don't we declare variable s with double type and assign 86.02. Then declare variable m with long type and assign s. Now, see, in this process, we got an error. Typecasting is required because long type is smaller than double type. Okay, good. So we choose Add Cast to Long as our option to add the casting operator with the long type, right? So let's declare variable c with byte type and assign m. And we get an error again. Typecasting required. Because byte type is smaller than long type. So let's go in and choose Add Cast to Byte as our option. Now we can print the values of these variables by using the print method. Now let's change the variable names and some other parts. Okay, let's run the code, and you can see the results in the console. Good job. Stack and heap. So stack and heap are used for allocating memory in Java. So in this section, we will completely understand how they work and when to use them for developing better Java programs. So basically, local variables, methods, primitive data types, and references of objects are all stored in a stack space of memory. Whenever a method is invoked, a new block is created in the stack memory for the method to hold local primitive values and reference to other objects in the method. Objects and reference types are stored in heap. So whenever we create any object, it's always created in the heap space of memory, and stack memory contains the reference to it. All right? So we're going to cover heap memory on the next few slides. I just want to make sure that you understand the difference. Stack memory size is much less compared to heap memory size. So if you know exactly how much data you need to allocate before compile time, and this data is not, too big, you should pretty much use stack. If you don't know exactly how much data you're going to need to allocate at runtime, or if you need to allocate just lots and lots of data, you should then, of course, use heap. So in this section, you'll learn how to work with arrays in Java. You're going to learn how to declare, instantiate, initialize, and access array elements. So what's an array? It's a container object that holds a fixed number of values of a single type. For instance, you can create an array that can hold 200 values of int type. Okay, so let's have a look at how to declare an array in Java. The array syntax is data type, square brackets, array name, or data type, array name, square brackets. Both are valid declarations. Data type can be primitive data like int, char, float, double, byte, etc. Array name is an identifier just like a variable. So in our example of an array declaration, int square brackets age means that age is an array that can hold int values. But how many elements can an array hold? So we defined in the initialization part of the slide, we allocate memory for array elements. So in our example, the length of the age array is 7. It means that it can hold 7 elements. The important point here is, after the creation of an array, the length is fixed. So what does that mean? It can't be changed in the program. Each item in an array is called an element. And each element is accessed by its numerical index. So shown here in the slide, index begins with 0. The fifth element, for example, would therefore be accessed at index 4. Initializing array values. So in Java, we can initialize arrays during declaration, or we can initialize later in the program. So in our example, this statement creates an age array and initializes it during declaration. The length of an array is determined by the number values provided, which is separated by a comma. The length of the age array is 7. Also, we can easily access and alter array elements by using a numeric index. And here in our example, we alter two values of age array at index 0 and at index 3. And new array values are located in the new area. Okay, so let's try to understand Java arrays with a few examples. That's my favorite method. So in the exercise project, right-click on the source folder and select New and Class. Specify package name as Array and the class name as Array, and select the checkbox to add main method. Right, so let's declare an int array, and its name is numbers. Size of numbers array is 4. And what does that mean? It can hold 4 numbers. So let's assign values to the elements of the array. So the first element of an array, and assign 4. Second element, assign 6. Third element, assign -3. And then the last element, assign it as -2. All right, so let's calculate the sum of array values. So now declare the variable sum with the int type and assign array elements by adding an index. Now let's print the sum of array values by using the print method. Okay, so let's run the code. And we see sum equals 5 in the console. So there's no need to assign a new variable. We can use elements of an array directly between parentheses in the print method. All right, so let's run the code again, and there we go. We see the same result. So now let's try to add an element with a 4th index. So let's run the code, and we get an error. Now, if we want to add an index that is either negative or greater than or equal to the size of the array, an array index out of bounds exception is thrown. So it's thrown only at runtime. The Java compiler does not check for this error during the compilation of a program. So let's declare an int array where its name is number with initial values 4, 6, -3, -2. We alter the value of the second element of the array with a new value, 12. So let's print the new sum of the array values by using the print method. And let's run the code. So the previous sum is 5, and after altering, the new sum is 11. All right, pretty cool, huh? Operators. So now the operators are special symbols that perform specific operations such as arithmetic, logical, etc. The value that the operator operates on is called the operand. For example, in the expression x plus 4, x and 4 are operands, and plus is an operator. So in this section, first we're going to learn the arithmetic, assignment, and unary operators. Then we're going to play with equality, relational, and conditional operators. Then we're going to learn operator precedence. Arithmetic operators. The Java programming language provides operators that perform addition, subtraction, multiplication, division, and remainder. So these are basic mathematical operations that you probably know and can do in your head. Plus is an additive operator. It adds two operands. Minus is a subtraction operator. It subtracts the right operand from the left. Asterisk is a multiplication operator. It multiplies two operands. / is a division operator. It divides the left operand by the right one. The type of division result is float by default. Now percent is a remainder operator. So this symbol might look new to you. It divides one operand by another and returns the remainder as its result. Okay, so let's try to understand Java operators with examples. So in the exercise project, right-click on the source folder and then select New and Class. Specify package name as Operator and the class name as Arithmetic Operator, and then select the checkbox to add main method. All right, so now let's declare three variables with the double type. First, number 1, and assign 8.4. Okay, second, number 2, and assign 4.2. And then last, result, with the initial value 0.0. So now you want to first assign number 1 plus number 2 to the variable result. All right, so let's show the result value by using our print method. And we may run the program after all the operations. Great, so let's copy the code and change the operator to the subtraction operator. And now change the operator in the print method. All right, so let's make changes for multiplication. Good, and we'll change it for division. And finally, let's change it up again for remainder as our operator. Okay, that's all. So let's run the code. And you see the result in the console. Number 1 plus number 2 equals 12.6. Number 1 minus number 2 equals 4.2. Number 1 multiplied by number 2 equals 35.28. Number 1 divided by number 2 equals 2.0. Number 1% number 2 equals 0.0. So the remainder is 0.